Hello to my second lesson on factorization. The first lesson was on why do we factorize and which cases we're going to use factorization for. Today we're going to get through the first method of factorization, which is the highest common factor. Before we start our lesson, just a big congrats to Lewis underscore 505 for solving that question on the Instagram page. Congrats, Lewis, and keep commenting on our videos and questions. I'm gonna put some challenging questions on Instagram too for you. Thank you. Highest common factor, the word factor, as we agreed, is a divisor. Common, so it must be a common divisor between two or more numbers, and then if there is more than a common factor, we're gonna choose the highest. So for example, if I'm asking you to find the highest common factor of 24 and 36, for example, both numbers are divisible by 2, both numbers are divisible by 4. Are both numbers divisible by 6? Yes, both numbers are divisible by 6, but the highest is 12. So the highest common factor in this case is 12. Both numbers can be divided by 12. 2, when it comes to a mathematical expression like 2x minus 6, 2x is divisible by 2 and divisible by x. 6 is divisible by 2 and divisible by 3, so the common factor between the two terms, 2x and 6, is 2. So we take 2 as a highest common factor, and then we open a bracket and we actually go for the division. 2x divided by 2, 2 will cancel, you get x inside, and then minus 6 or negative 6 divided by positive 2, I'm gonna get a negative number. 6 divided by 2, I'll get the 3. In order to confirm that your factorization is right, actually go for expanding. So 2 will be multiplied by each term inside. If you get that mathematical expression back, your factorization is right. So 2 times x is 2x. 2 times negative 3 is negative 6. Yes, I got that mathematical term right, so my factorization is right. And then I can, when I look at this one here, I can say that this mathematical term can be divided by 2 or can be divided by the bracket x minus 3. Now, example 3, I'm gonna go a little bit harder. So the question is to factorize, and I have 3a squared minus 6a. Now, let's see. The first term, which is 3a squared, is divisible by 3, divisible by a, and divisible by a squared. Now, this term is divisible by 2, by 3, by 6, and by a. The common factor here is 3, and then a, because this can be, a squared can be divided by a, and a can be divided by a. And then when I open the bracket, I'll actually go for the division. 3a squared divided by 3a, I will get a left in there. And then minus 6a divided by 3a, a will cancel, 6 divided by 3 is a 2. When I expand, 3a times a, I get 3a squared, which is my first term up there. And then 3a times negative 2 is negative 6a, which is my second term here. So I know that this factorization is right. And I can tell that this term, this mathematical expression here, is divisible by 3, is divisible by a, is divisible by the bracket a minus 2. Example 4. Again, the question is to factorize, and I have 3 terms here. 3 x squared y cubed b to the power of 4 minus 6 x y to the power of 3 b squared plus 9 x squared y squared and b squared. Now when we look at the numbers 3, 6 and 9, they all divisible by 3. Now when we look at the x's, I have x squared, I have x, and I have x squared. They all can be divided by x. When we look at the y's, I have y cubed, and then y squared. So y squared is the one to get. b4, b2, b2, I'll get b squared here. And then I'll open my bracket. And then I'll divide each term by the highest common factor. 3 and 3 will cancel. X squared divided by x, I'll get 1x left in there. Y cubed divided by y squared, I get y. y4 divided by y squared, sorry, b4 divided by b squared is b squared. Then a negative divided by positive is a negative. 6 divided by 3 is a 2. X will cancel. Y cubed divided by y squared is y. B squared will cancel. And then positive divided by positive is positive. 9 divided by 3 is 3. X squared divided by x, I'll get x left in there. And then y squared will cancel, b squared will cancel, so I'll get this as my factorization. From here, this term is divisible by 3, divisible by x, divisible by y or y squared, divisible by b or b squared, and divisible by this bracket too. Example 5, and this one we include brackets. So if I have example 5, the question is to factorize, and I have ab squared, let's put it 4ab squared outside of x minus y minus 8 a squared b outside of x minus y all squared. Now 4, because 4 and 8 both can be divided by 4, a and a both can be divided by a, b squared and b both can be divided by b, and then these two actually can be divided by the bracket x minus y. Then I open my bracket. First term, when divided by that, I'll get b left in there, because the bracket will cancel, a will cancel, and 4 will cancel. Minus 8 when divided by 4, I'll get the 2. A squared when divided by a, I'll get the a. B will cancel, and the bracket I have here x minus y all squared, which means 2 of those brackets multiply by each other. One of them will cancel with x minus y, and I'll get x minus y inside. Is this possible to have 2 brackets inside each other? Yes. And if you want to expand this one, I can go simply say this will end up as 4ab outside of x minus y bracket b, and then minus 2a times x is minus 2ax, negative 2a times negative y is positive 2ay, and then I get these 2 brackets. This is how to use the highest common factor as a way or a method of factorization. Second method of factorization, number 2, is the difference of 2 squares. So example, it's not an example, it's in this form, x squared minus a squared, and the way we factorize, I'll take the square root of the first term, which is x, the square root of the second term, which is a. Once I'll add them, and once I subtract them. And to prove it is very easy. If I expand this, I must get back to this term. So x times x will end up as x squared. X times negative a is negative ax. This term is already multiplied by these 2, so this is done. Now I'll get this term, which is positive a times x, I'll get positive ax, and then positive a times negative a, I'll get negative a squared. These 2 terms will cancel, and I will end up with x squared minus a squared. So once we see 2 square numbers or terms and the operation is subtraction, I can actually factorize these 2 subtracted terms into 2 multiplied quantities in this form. and I'll show you a way I want you to use, which is gonna make your life easy. If I have factorize, and these questions, number 1 is x squared minus 9, number 2 is 4y squared minus 25, number 3 is 9 a squared b squared minus 25 x squared y to the power of 4, number 4 is x to the power of 4 minus 49. We'll go one by one here. In number 1, the question is x squared minus 9. First, I can see that x squared is a square number and 9 is a square number. So my way always is to make sure that the two are to the power of 2. So x squared, what a symbol I put in the, when I square it I get x squared, simply it is x. Minus is a minus, and what number you square it, you get a 9, you get a 3. And then simply I'll create my two brackets by taking the square root of x squared, which is x, the square root of 3 squared, which is 3. Once I'll add them and once I'll subtract them. Number 2 is 4y squared minus 25, using the same methods. First, make sure it is something squared minus something squared. What number I put here, so when I square it I get a 4, it is a 2, and this must be a y. When you square it you get the y squared. What number you put there to get 25? Definitely it's a 5. Now it's very easy, 2y once you add it to the 5 and 2y once you subtract it. Now number 3 here is 9a squared b squared minus 25 x squared y to the power of 4. I want that to be something squared minus something squared, and from there it's easy. What number you put there when you square it you get a 9, it is a 3. I need to put a pronumeral. When I square it I get a squared, so it is a, and then b is using the same method. And if you want to confirm, 3 squared is a 9, a to the power of 1 squared is a squared, b squared is b squared. Then here simply it will be 5, and then I'll put x, and here might be a tricky. To get y to the power of 4, this must be y squared. Now, can I now simply solve? Yes, you take these two terms without the squaring, or the square root of these two terms, and once you add them, so I'll get 3ab plus 5xy squared in a bracket multiplied by 3ab minus 5xy squared in the second bracket. In number 4, and this you need to factorize fully, so if you have a factorization process must be done and you leave it there, so you're going to lose a mark for sure. So I have x to the power of 4. In number 4 I have x to the power of 4 minus 49. Can I make it something squared minus something squared? Yes, and this will be x squared minus 7, because 7 squared is 49, and simply I'll start with x squared minus 7 and multiply by x squared plus 7. If you leave it there you lose 1 mark. Why? Because this can be factorized. This is a square number or a square pronumeral, and this is tricky, but we can go for, if I want to express it, what a number when you multiply by itself twice you get a 7, it's square root of 7. So simply I can complete factorizing x minus root 7 x plus root 7 for this one, and then this will be multiplied by x squared plus 7, and we cannot factorize here because it is the difference of two squares, not the sum of two squares, and this is the end of the question. These were the two methods of factorization we learned today. One more thing, just when it comes to if I have more than one factorization method, like for example the question is to factorize and you have two methods of factorization. They like 2x squared minus 50. I can say that this is a difference of two squares, but there is a highest common factor of 2. Which one to start with? Always and forever start with taking the highest common factor, then any other factorization method. So in here, my first method will be take the 2. This will end up as x squared minus 25, and then don't forget to put the 2 down. This will end up as x plus 5 multiplied by x minus 5, as we learned previously. Our next two methods of factorization will be the sum and difference of two cubes. I'll see you next lesson. Thank you so much.